Hello students, I am Chaithra, Assistant Professor of Mathematics from Canara Engineering College. In this video, let us discuss the second part of Module 3, Z transforms. The basic idea of the Z transform was known to Laplace and it was reintroduced in 1947 by Witold Hurewicz. Fourier transforms are for converting or representing a time-varying function in the frequency domain. Z transforms are very similar to Laplace but are discrete time interval conversions closer for digital implementations. They all appear the same because the methods used to convert are very similar. Z transform is used to convert discrete time domain signal into discrete frequency domain signal. It has wide range of applications in signal processing. It is mainly used to analyze and process digital data. Z transform of a function is defined as given a function un for the discrete values of n. Z transform of un is summation un z to the power minus n wherever n is running from 0 to infinity, which is a function of z. Let me concentrate on one of the important property of Z transform, linearity. That is, if A and B are any two constants, then Z transform of A into Un plus B into Vn can be written as A into Z transform of Un plus B into Z transform of Vn. Before proceeding to the problems on Z transform, let us first see the Z transform of standard functions. So the first function over here is a power n. That is, Z transform of a power n is z by z minus a. You can prove this by using the definition of Z transform. Z transform of un is summation un z to the power minus n wherever n is running from 0 to infinity. Here your un is a power n. Just do the substitution. You'll get Z transform of a power n is summation n from 0 to infinity a power n into z to the power minus n. You can write it as summation n from 0 to infinity a by z whole raised to n. Expand the summation. For n is equal to 0, the first term is 1. For n is equal to 1, the second term is a by z. For n is equal to 2, the third term is a by z whole square. For n is equal to 3, the fourth term is a by z whole cube, and so on. This is nothing but the geometric series, and you know the infinite sum of your geometric series, and is given by 1 divided by 1 minus a by z. Do the simplification. You will get Z transform of a per n is z by z minus a. However, the proof is not required for exam. Okay, we will see the example now. Z transform of, say suppose 2 power n. which is z by z minus 2. This is because your a is 2 here. Similarly, you can get z transform of minus a power n, which is z by z plus a. For example, z transform of minus 5 power n, that is z by z plus 5. It is important to note that z transform of 1 can also be written as z transform of 1 power n, that is equal to z by z minus 1. Just compare your a is 1 here, so z by z minus 1. So z transform of 1 is z by z minus 1. Here is one problem. Find the z transform of cosine theta and sine theta. How you can find the z transform of cosine theta and sine theta? However, you can get the result of both these functions using exponential. That is, z transform of cosine theta plus I sine theta is equal to z transform of e power I n theta. You can write your cosine theta plus I sine theta as e power I n theta, which can be transformed as e power I theta whole power n, which is of the form now z transform of a power n. A is e power I theta, and you know z transform of a power n, which is z divided by z minus a. So z transform of e power I theta whole power n is z divided by z minus e power I theta. What is your e power I theta? It is nothing but cos theta plus I sin theta. By substituting, you will get z divided by z minus cos theta minus I sin theta. In order to separate the real and imaginary part, multiply and divide by the conjugate of the denominator. So the above equation reduces to the form z transform of cosine theta plus I times z transform of sine theta, which is equal to z into z minus cos theta divided by z square minus 2z cos theta plus 1 plus I times z sin theta divided by z square minus 2z cos theta plus 1. Now comparing the real and imaginary parts, we'll get z transform of cosine theta is z into z minus cos theta divided by z square minus 2z cos theta plus 1, and z transform of sine theta is z sin theta divided by z square minus 2z cos theta plus 1. Here is a result that also helps us to find the z transform of some function. Z transform of n into un is minus z into the first derivative of z transform of un. Using this result, we can easily find z transform of the following. Z transform of n is, I can write it as z transform of n into 1. From the above result, this is nothing but minus z into the first derivative of z transform of 1, which is equal to minus z into d by dz of, what is z transform of 1? It is z by z minus 1. Just apply the quotient rule. So the resultant is z transform of n is equal to z by z minus 1 whole square. Similarly, Z transform of n square can be written as Z transform of n into n, which is equal to minus Z into d by dz of Z transform of n. That is equal to minus Z into d by dz of Z by Z minus 1 whole square. On simplification, we get Z transform of n square is Z square plus Z divided by Z minus 1 whole cube. Similarly, we can get Z transform of n cube, which is equal to Z cube plus 4Z square plus Z divided by Z minus 1 whole to the power 4. Let me now consider the combination of n and cos n theta. That is, Z transform of n cos n theta can be written as minus Z into d by dz of Z transform of cos n theta, which is equal to minus Z into d by dz of what is your Z transform of cos n theta? It is Z square minus Z cos theta divided by Z square minus 2Z cos theta plus 1. Applying the quotient rule, you'll get minus Z into Z square minus 2Z cos theta plus 1 into 2Z minus cos theta minus Z square minus Z cos theta into 2Z minus 2 cos theta divided by Z square minus 2Z cos theta plus 1 whole square. On simplification, you'll get Z transform of n cos n theta as Z into Z square cos theta plus cos theta minus 2Z divided by Z square minus 2Z cos theta plus 1 whole square. We will move on to the next problem. Z transform of cos hyperbolic n theta and sin hyperbolic n theta. I can express cos hyperbolic in terms of exponential, so that Z transform of cos hyperbolic n theta is Z transform of e power n theta plus e power minus n theta divided by 2, which is equal to half times Z transform of e power n theta plus e power minus n theta, which is of the form Z transform of a power n. This is because you can write your e power n theta as e power theta whole power n. Similarly, e power minus n theta as e power minus theta whole power n. Applying the standard result, you'll get Z transform of cos hyperbolic n theta as half times Z divided by Z minus e power theta plus Z divided by Z minus e power minus theta. On simplification, you'll get half times 2Z square minus Z into e power theta plus e power minus theta divided by Z minus e power theta into Z minus e power minus theta. Just note down, your e power theta plus e power minus theta is 2 times cos hyperbolic theta. Similarly in the denominator, so that it will reduce to the form Z into Z minus cos hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. In the same way, we can even find the z transform of sine hyperbolic n theta, which is equal to z sine hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1. Damping rule. If z transform of un is u of z, then z transform of a power n into un is u of z by a, and z transform of a power minus n into un is u of a into z. Now we will solve the problems related to the above rule. Z transform of 2 power n cos hyperbolic n theta, that is equal to z transform of cos hyperbolic n theta, wherever z replaces to z by 2. What is z transform of cos hyperbolic n theta? Which is equal to z into z minus cos hyperbolic theta divided by z square minus 2z cos hyperbolic theta plus 1, wherever z changes to z by 2. Replacing z by 2, we'll get z by 2 into z by 2 minus cos hyperbolic theta divided by z by 2 whole square minus 2 times z by 2 cos hyperbolic theta plus 1. Then on simplification, z transform of 2 power n cos hyperbolic n theta is z into z minus 2 cos hyperbolic theta divided by z square minus 4z cos hyperbolic theta plus 4. Next problem. Z transform of e power minus an sin n theta. I can rewrite it as z transform of e power a whole raised to minus n. Then by the above rule, this is equal to z transform of sin n theta, where z changes to e power a z, which on simplification reduces to the following: e power a into z sin theta divided by e power 2a z square minus 2 times e power a into z cos theta plus 1. We'll see some problems on z transform. Find the z transform of n minus 1 whole square, 2 power n plus 3, 2n plus 5 sin n pi by 4 minus 3a to the power 4 and sin of 3n plus 5. First problem, z transform of n minus 1 whole square. It is of the form a minus b whole square. You know it, a square minus 2ab plus b square. So z transform of n minus 1 whole square is z transform of n square minus 2n plus 1, and you know z transform is linear. You can split the z transform, so it becomes z transform of n square minus 2 times z transform of n plus z transform of 1, and z transform of n square is z square plus z divided by z minus 1 whole cube minus 2 times z transform of n is z divided by z minus 1 whole square plus z transform of 1 is z by z minus 1. On simplification, we will get z transform of n minus 1 whole square as z cube minus 3z square plus 4z divided by z minus 1 whole cube. Next problem, z transform of 2 power n plus 3. You can write your 2 power n plus 3 as 2 power n into 2 power 3. Again, 2 power 3 is a constant term, you can take outside. So it becomes 2 power 3 into z transform of 2 power n. What is your z transform of 2 power n? It is z by z minus 2. So the answer is 8z divided by z minus 2. The next problem, z transform of 2n plus 5 times sin n pi by 4 minus 3a to the power 4. It can be written as 2 times z transform of n plus 5 times z transform of sin n pi by 4 plus 3a to the power 4 times z transform of 1. Again, z transform of n is z by z minus 1 whole square. So it becomes 2 times z divided by z minus 1 whole square plus 5 times z sin theta. Theta is pi by 4. So sin pi by 4 divided by z square minus 2z cos pi by 4 plus 1 minus 3a to the power 4 is a constant term. Z transform of 1 is z by z minus 1. Z transform of sine of 3n plus 5. You know the z transform of sine n theta, but here it is sine of 3n plus 5. How you can find the z transform of sine 3n plus 5? You know sine of a plus b, right? Sine of a plus b is sine a cos b plus cos a sine b. Apply the formula. Sine of 3n plus 5 becomes sin 3n cos 5 plus cos 3n sin 5. Therefore, z transform of sin 3n plus 5 is z transform of sin 3n cos 5 plus cos 3n sin 5. Just observe here, cos 5 and sin 5 are the constant term, right? Take out from the z transform. So it becomes cos 5 into z transform of sin 3n plus sin 5 into z transform of cos 3n. Again, you know the z transform of sin n theta and cos n theta, correct? So what is theta here? 3, right? Apply the z transform formula of sin n theta and cos n theta. So it becomes cos 5 into z sin 3 divided by z square minus 2z cos 3 plus 1 plus sin 5 into z minus cos 3 divided by z square minus 2z cos 3 plus 1. On simplification, you'll get z transform of sine of 3n plus 5 as z square sin 5 minus z sin 2 divided by z square minus 2z cos 3 plus 1. Next is shifting rule. Z transform of un minus k is equal to z to the power minus k into u of z. And z transform of un plus k is equal to z to the power k into u of z minus u naught minus u1 by z minus u2 by z square minus and so on. The last term is uk minus 1 by z to the power k minus 1. Just make a note, whenever the sequence un plus k is given, the last term is still k minus 1. In particular, for n is equal to 1, the transform of un plus 1 is z into u of z minus z into u naught. For 1, k is 1. So k minus 1, 1 minus 1, 0. Similarly, z transform of un plus 2 is equal to z square into u of z minus z square into u naught minus z into u1. And so on. Here is one problem on shifting rule. Find the z transform of 1 by n factorial and hence find z transform of 1 by n plus 1 factorial and z transform of 1 by n plus 2 factorial. We will first see z transform of 1 by n factorial. By the definition of z transform of un is summation un into z to the power minus n wherever n is running from 0 to infinity. So that z transform of 1 by n factorial becomes summation 1 by n factorial into z to the power minus n wherever n is running from 0 to infinity. Give the values for n. For n is equal to 0, the first term is 1. For n is equal to 1, the second term is z to the power minus 1 by 1 factorial. For n is equal to 2, the third term is z to the power minus 2 by 2 factorial. For n is equal to 3, the fourth term is z to the power minus 3 by 3 factorial, and so on. This is nothing but e to the power z to the power minus 1. Since e to the power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, and so on. Go in a reverse direction. So 1 plus z to the power minus 1 by 1 factorial plus z to the power minus 2 by 2 factorial plus so on becomes e to the power z to the power minus 1. This is nothing but e to the power 1 by z. And this nothing but your u of z. Now, hence find z transform of 1 by n plus 1 factorial and z transform of 1 by n plus 2 factorial. Let un is equal to 1 by n factorial. Then un plus 1 becomes 1 by n plus 1 factorial. Your n becomes n plus 1, so it is 1 by n plus 1 factorial. And un plus 2 is 1 by n plus 2 factorial, and u naught and u1 value. N is 0, then 1 by 0 factorial, 0 factorial is 1, so u naught is 1 and u1 is, n is 1, so 1 by 1 factorial, your u1 value is 1. Now by shifting rule, z transform of un plus 1 is z into u of z minus z into u naught, and z transform of un plus 2 is z square into u of z minus z square into u naught minus z into u1. Therefore, z transform of 1 by n plus 1 factorial is z into u of z. U of z is e to the power 1 by z minus z into u naught. U naught value is 1. So z into 1. Therefore z transform of 1 by n plus 1 factorial is z into e to the power 1 by z minus z. Similarly, z transform of 1 by n plus 2 factorial. It is z square into u of z. U of z is e to the power 1 by z. So, z square into e to the power 1 by z minus z square into u naught. U naught value is 1. So, z square into 1 minus z into u1. U1 value is 1. So, z into 1. Therefore, z transform of 1 by n plus 2 factorial is z square into e to the power 1 by z minus z square minus z. Next is initial value theorem. Q naught can be written as limit u of z as z tends to infinity. U1 is equal to limit of z into u of z minus z into u naught as z tends to infinity. Similarly, u2 is equal to limit of z square into u of z minus z square into u naught minus z into u1 as z tends to infinity. And u3 is limit of z cube u of z minus z cube into u naught minus z square into u1 minus z into u2 as z tends to infinity, and so on. And final value theorem. Limit un as n tends to infinity is limit z minus 1 into u of z as z tends to 1. Here is a problem of initial value theorem. If u of z is equal to 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4, find the values of u2 and u3. To get u2 and u3, first you should know u0 and u1. By initial value theorem, u0 is limit u of z as z tends to infinity. By substituting u of z, u0 becomes limit z tends to infinity 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4. Just observe, the degree of the numerator is less than the degree of the denominator. Therefore, your u0 is 0. Next is u1 and is equal to limit of z into u of z minus z into u0 as z tends to infinity. Substituting u of z and u0, you will get u1 as limit z tends to infinity 2 into z cube plus 3 into z square plus 12 into z divided by z minus 1 whole to the power 4. Note that the degree of the numerator is less than the degree of the denominator. Therefore, your u1 is also 0. Now, u2 and is equal to limit of z square into u of z minus z square into u0 minus z into u1 as z tends to infinity. By substituting u of z, u0 and u1, u2 becomes limit z tends to infinity 2 into z to the power 4 plus 3 into z cube plus 12 into z square divided by z minus 1 whole to the power 4. Take z to the power 4 outside from the numerator as well as the denominator so that you can cancel the term which is giving trouble to apply the limit. After applying the limit, the value of u2 is 2. The last term is u3 and is equal to limit of z cube into u of z minus z cube into u0 minus z square into u1 minus z into u2 as z tends to infinity. By substituting u of z, u0, u1 and u2, we will get u3 as limit z tends to infinity z cube into 2z square plus 3z plus 12 divided by z minus 1 whole to the power 4 minus 2z. You can't directly apply the limit. Further simplification is needed. By taking the LCM, your u3 becomes limit z tends to infinity 2 into z to the power 5 plus 3 into z to the power 4 plus 12 into z cube minus 2 into z to the power 5 plus 8 into z to the power 4 minus 12 into z cube plus 8 into z square minus 2z divided by z minus 1 whole to the power 4. Cancel 2 into z to the power 5 and take z to the power 4 outside and then apply the limit. You will get the value of u3 and is equal to 11. Just practice these problems, students, so that you can understand the concept of Z transform in a better way. Thank you.